We're now going to look at the data and how we can start interpreting the data. If we have, and most of the data we'll be talking about will be data in one variable. It's called univariate, one variable. Data can be described using measures of central tendency. So if you just have one piece of data and you're looking at that one piece of data, you can then calculate its mean, which would be the sum of all the data divided by the number of items. The median, which is the middle number. If you've got an odd number of numbers, it'd be the middle number if the data is put in order, or the mean of the two middle numbers if the data is put in order. If it's an even number, there'll be two numbers in the middle, and you just have to find the average of those two. And the mode is the number or thing that occurs the most often, and sometimes there's actually more than one mode. Now, when to use which? The mean is best used when there are no outliers. An outlier is a piece of data that just doesn't match the rest of the data. Median is great to use if there is outliers, but there are no big gaps in the middle. All right, in other words, if the mean is 17 and there's no data around 17, then the median is not a good thing to use. Probably the mean would be. And the mode is the one that occurs most often, so you best use that when you have many of the numbers that are repeating. When we talk about the data, we talk about its parameters, the measure that describes the characteristics of the population. What is it we're measuring? Are we measuring the height? Are we measuring the distance or the time? Statistic is the measure that describes that characteristic. What is the number that you are collecting? And when you collect that data, and when you take a small sample, a sample from the population, it means you're not going to be asking everybody. There's a risk of sampling error. As the size of the sample increases, the margin of the error decreases. So if you just ask two people what their favorite song is, then you may get the same song, and therefore you would predict that everybody likes that song. But if you ask 15 people and got various different answers, then you might say that another song is the favorite. So the more people that you include in your survey or in your data, the better chance you have of getting a low margin of error. And this margin of sampling error provides an interval that shows how much the responses from the sample would differ from the population. So you take whatever piece of data, the mean, median, and the mode, usually the mean, and you would calculate its measure of sampling error. And that is calculated by adding and subtracting 1 over the square root of n. N in this case would be the number of things that you are taking a sample of. Again, the higher the sample, the lower this number is. And you'll see that as you do some problems today. And the last two measures are measures of how spread out the data is. Measures of variance, measures of variation describe the dispersion or the spread of the set of data. Variance is one of those. It describes how closely a set of data clusters about the mean. And another measure of variation is standard deviation. It's actually a calculation. And the calculation goes this way. If you're using a sample, the sample standard deviation would be the sum of all of the numbers subtracted from the mean, added together. That's the sum of all of the numbers subtracted from the mean, squared, divided by the number of numbers minus 1, and then you take the square root of that number. For the population, if you're testing the whole population, then we use a Greek letter called sigma, which represents the standard deviation of the population. And again, we take the sum of all of the numbers subtracted from the mean, squared, divided by the number of numbers. In this case, x bar, and that's the way you pronounce it, x bar, is the sample mean, and mu, and this is a Greek letter mu is the population mean. And that these two Standard deviation and variance will describe how spread out the data is.